Scientists just found new evidence for the existence of Planet X. A hypothetical superterrestrial planet is estimated to have a mass 5 to 10 times that of Earth and an orbit that extends 400 to 800 times farther from the Sun than Earth. The orbit estimate was refined in 2021, resulting in a semi-major axis. Constantine Batigin and Michael E. Brown suggested that Planet 9 could be the core of a giant planet that was ejected from its original orbit by Jupiter during the formation of the solar system. Others argue that the planet was captured by another star, was once a rogue planet, or formed in a distant orbit and was pulled into an eccentric orbit by a passing star. In today's video, we are going to explain everything you need to know regarding Planet X. But before we move forward in the video, make sure to subscribe for more content and like this video for receiving similar suggestions from YouTube. Also, we highly appreciate your comments. Now let's get straight into the video. Planet 9 is a hypothetical planet in the outermost region of the solar system. Its gravitational effect could explain certain orbital clustering for a group of extreme trans-Neptunian objects, ETNOs. Objects beyond Neptune that orbit the Sun at an average distance of more than 250 times Earth's distance. These ETNOs tend to be closest to the Sun in one sector, and their orbits tend to be the same. This alignment suggests that as yet undiscovered planets can control the orbits of the most distant objects known in the solar system. However, some astronomers have questioned the hypothesis that a hypothetical planet exists, arguing that the clustering of ETNO's orbits is due to observational bias associated with difficulties in detecting and tracking these objects. The largest studies, such as the Wide Field Infrared Survey Explorer, WISE, and Pan-STARRS, have neither detected Planet 9 nor ruled out the presence of Neptune diameter objects outside the solar system. The ability of previous celestial studies to find Planet 9 depended on its location and characteristics. Further research in other areas will continue with the help of NEOWISE and the 8-meter Subaru telescope. Until Planet 9 is discovered, its existence cannot be suspected by anyone. Several alternative hypotheses have proposed to explain the observed clustering of trans-Neptunian objects, ETNOs. Since Neptune was discovered in 1846, there has been much speculation that other planets may exist outside its orbit. The most famous of these theories predict the existence of distant planets affecting the orbits of Uranus and Neptune. After extensive calculations, Percival Lowell estimated the possible orbits and positions of a hypothetical trans-Neptune planet and began a thorough search for it in 1906. He named the hypothetical object Planet X, a name previously used by Gabriel Delet. Clyde Tombaugh continued his research for Lowell and discovered Pluto in 1930, but was soon determined that he was too young to qualify as Planet X Lowell. After Neptune flew over Voyager 2 in 1989, it was determined that the discrepancy between the predicted and observed orbits of Uranus was due to the previously inaccurate use of Neptune's mass. Attempts to find planets beyond Neptune through indirect means, such as orbital disturbances, predicted the discovery of Pluto. One of the first was George Forbes, who postulated the existence of two trans-Neptunian planets in 1880. One would be at an average distance from the Sun or a semi-major axis of 100 astronomical units, AU, 100 times more than Earth. The second one will have a large wick of 300 AU. His work is considered similar to the more recent theory of 9 planets, in which the planets would be responsible for grouping the orbits of some objects, in this case, grouping the aphelion distances of the periodic comet near 100 and 300 AU. This is similar to the accumulation of Jupiter's comet aphelion distance near its orbit. The discovery of Sedna's special orbit in 2004 led to speculation that it had discovered a large object other than one of the known planets. Sedna's orbit is separate, at a perihelion distance of 76 AU, which is too large to be due to gravitational interactions with Neptune. Some authors have suggested that Sedna entered this orbit after encountering a large object, such as an unknown planet in a distant orbit, a member of an open star cluster that formed with the Sun, or another star that later passed close to the solar system. The March 2014 announcement of the discovery of a second perihelion distance sphenoid 80 AE 2012 VP113 in the same orbit led to renewed speculation that an unknown super-Earth remains in the distant solar system. At a conference in 2012, Rodney Gomez suggested that an undiscovered planet was responsible for the orbits of several split-orbit ETNOs and the main semi-major axis of Centauri, the small solar system body that intersects the orbits of the giant planets. The proposed Neptune mass planet would be in a distance approximately 1500 AU, eccentric, and 40 degrees tilted orbit. Like Planet 9, this would cause perihelion to vibrate in objects with a semi-major axis greater than 300 AU, placing some in orbits that intersect the planets and others in separate orbits like Sedna. In 2015, an article by Gomez, Suarez, and Brasser was published detailing their arguments. In 2014, astronomers Chad Trujillo and Scott S. Shepard noted similarities in the orbits of Sedna in 2012 VP113 and several other ETNOs. They suspect that an unidentified planet orbiting in a circle between 200 and 300 AU is interfering with this orbit. Later that year, Raul and Carlos de la Fuente Marcos argued that two massive planets in orbital resonance were needed to produce the similarity of so many orbits known at the time. Using a larger sample of 39 ETNOs, they estimated that the closest planet has a semi-major axis in the 300 to 400 AU range, relatively low eccentricity, and an inclination of nearly 14 degrees. Planet 9 was originally thought to follow an elliptical orbit around the Sun with an eccentricity of 0.2 to 0.5, and its semi-major axis was estimated at 400 to 800 AU, which is about 13 to 26 times the distance from Neptune to the Sun. It takes between 10,000 and 20,000 years for the planet to fully orbit the Sun, and its tilt with respect to the ecliptic, the plane of Earth's orbit, has been predicted to be between 15 degrees and 25 degrees. Aphelion, or the farthest point from the Sun, lies in the general direction of the constellation Taurus, while perihelion, the closest point to the Sun, lies in the general direction of the southern regions of Serpens, Caput, Ophiuchus, and Libra. Brown believes that if Planet 9 is confirmed, a probe could reach it in just 20 years, losing a propulsive orbit around the Sun. The planet is estimated to be 5 to 10 times the mass of Earth and 2 to 4 times the radius of Earth. Brown believed that if a Planet 9 existed, its mass would be sufficient to clear its orbit of major objects within 4.5 billion years of the solar system's age, and that its gravity would dominate the outer edge of the solar system, enough to create it a planet by today's definition. Astronomer Jean-Luc Margot also said that Planet 9 met its criteria and would qualify as a planet if and when found. The gravitational influence of the 9 planets would explain 4 features of the solar system: ETNO orbital grouping, high perihelion objects such as 90377 Sedna, apart from Neptune's influence, high slope ETNO with orbits approximately perpendicular to the orbits of the 8 known planets, and a highly inclined trans-Neptune T&E object with a semi-major axis below 100 AU. Planet 9 was originally proposed to explain the clustering of orbits with a mechanism that would also explain the high perihelion of objects like Sedna. The evolution of some of these objects in vertical orbits was unexpected, but was found to be consistent with previously observed objects. It was later discovered that the orbits of some objects with perpendicular orbits evolved to smaller semi-major axes when other planets were included in the simulation. Although other mechanisms have been proposed for many of these features, Planet 9's gravitational influence is the only one that explains all 4. However, Planet 9's gravity would also increase the tilt of other objects crossing its orbit, but this could leave scattered disk objects, objects behind Neptune with semi-major axis greater than 50 AU, and short-period comets spreading more widely over the Earth's slope than observed. Planet 9 was previously thought to be responsible for the 6-degree tilt of the Sun's axis relative to the planet's orbits, but recent updates to the predicted orbits and mass limit this shift to around 1 degree. With that said, we have reached the end of our video. Like this video and subscribe to his YouTube channel if you have not done yet. Sharing is a way of caring. Share this video to spread the knowledge and let us know in the comment section, what do you think about the existence of Planet X? See you next time. Thanks for watching.